This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. In this video, I'm going to be going through the first 3 derivations that are required on the Leaving Certificate Higher Level Trigonometry course. The first derivation that's required is cos squared A plus sine squared A equals 1. The way this is usually done is by drawing a unit circle like this one here. So the unit circle has radius of length 1. In the x direction we just have cos A, in the y direction we have sine A. The reason for that being is in the unit circle, when we write sine of our angle A here, sine of A is our opposite over our hypotenuse. So if our opposite is just of length y, and our h is just 1, so that means y is equal to sine A. So we just have sine A along the y. And similarly, we can find that the x is just cos A. So once we've done that, all we need to use then is our Pythagoras Theorem. So we know that Pythagoras Theorem says h squared is equal to o squared plus a squared. So filling in our o and our a as cos and sine, we get that cos squared a plus sine squared a is equal to 1 squared. 1 squared is just 1, so we have cos squared a plus sine squared a equals 1. The next derivation we're going to look at is the sine rule formula. And there are 2 cases that we have to look at in this derivation, the acute case and the obtuse case. So looking at the acute case first, we have a diagram which will look like this, where we have our angle A and B labeled as appropriately, and the opposite sides labeled, with a vertical height in the middle of y. So, using the 2 right-angled triangles, our triangle with angle A, using this right-angled triangle, we can say that sine A is equal to y over b, our opposite over our hypotenuse. Using our second triangle here with the angle B, again right-angled triangle, we can say that sine of b is y over a, again our opposite over our hypotenuse. And then we can just rewrite these 2 expressions to be b sine a is equal to y, and a sine b is equal to y. That's just multiplying up this b and this a respectively. So then we have 2 expressions which are equal to y, which means we can set the 2 of them equal to each other. So b sine a is equal to a sine b, and just rearranging that, putting our 2 signs on, dividing both sides by sine a and sine b, we get b over sine b is equal to a over sine a, and that's our formula for the acute case. Now the second case we have to consider is the obtuse case, where instead of y, the vertical height y being inside the triangle, it is outside the triangle here instead. So for this, we're going to be drawing our angle B and an angle A here, and since we have a straight line along here, that means this angle here, highlighted in green, is 180 degrees minus this angle A here. And then again, we're going to look at 2 separate right-angled triangles. First, we look at this one on the outside here. So we have sine of our angle 180 minus A is equal to y over b, our opposite over our hypotenuse. And in the second triangle we're going to look at, is the whole triangle here. So this whole triangle on the outside. So in that triangle, our hypotenuse is A, our angle is B, and our opposite is y again. So we have sine B is equal to opposite over hypotenuse y over A. Just as above, we're going to rearrange these two expressions to get y equals, which means we can set the two values equal to each other. Once we do that, we have b, once again we can divide by sine A and divide by sine B on both sides to get our expression b over sine B is equal to A over sine A. And lastly, we just have to write that we can similarly show that A over sine A is equal to C over sine C just by relabeling some of these angles up above. So therefore, we have A over sine A equals B over sine B equals C over sine C, and we're done. QE.